HSM was a standalone company that offered 2.5 axis for free as part of their marketing up until about 2012 when Autodesk bought them. They were a gold partner CAM package until Autodesk bought them. And then how do you have a competitor be a gold partner? It's kind of one of those ironic situations that as soon as HSM was purchased, then they were no longer a gold partner, although they still have quite a bit of embedded code in working inside of SolidWorks. So just like the Mastercam add-in, I came up to add-ins. I went to HSMworks. I activated it. Now it's good for this session. So my seed of HSM is a commercial version that purchased with Fusion 360, and as long as Autodesk wants my whatever it is, $500 a year, I will probably be using HSM. So the same basic process that we went through. We have a tab with CAM on it, and then we have another tab that is the list of operations. And so HSM should probably talk about learning curves. I mentioned that in Mastercam, you kind of have that transferability from the standalone version over into the Solids. A lot of the same type of operations, just maybe a little bit different in the setup as we just showed. HSM has a pretty light learning curve. Some of the operations may seem a little bit weak. There are, at least when I first started using it, it seemed like it could do, should do a lot more. What it does well, and you don't have a very high learning curve for using it. So where we're setting up our stock and our OR coordinates is in the job. So we either come to the right click. If you haven't noticed already, I am heavy on the right mouse button click, so new job. Or if you come up to the ribbon, then we'll go to the job. But under new job, we have the model, and if I had multiple bodies, say I had a stock body or I had fixtures or I had something else, I wouldn't necessarily include them. So this is filtering out just the model entities that are going to be machined. The stock is set to from solid. I could also go to a relative size box and just say no additional stock. Whatever size is whatever size. If you watched any of my HSM videos from 2, 3, 4 years ago, they did not have the work coordinate system this well defined. They had the origin and orientation, and one of the problems is that you could not rotate the orientation very easily. So we ended up just setting SolidWorks coordinate systems and picking those as our defaults. With the UZ axis and X axis, that's made it a lot more functional. So I'm going to pick the front face, which aside from the color issues that did select correctly, and then the X direction is going to be a line, and lastly the origin is going to be the vertex, and pretty much lying at the origin. My program name is program 1, and the comment will be whatever I want for the description. We're setting the block, except I can't spell block. There we go. And then if we do a work offset, maybe I want to go from G54 to 55. So very similar to Mastercam in that respect is 0 and 1 are G54. And if we go up to 2, then it's G55, 3, G56, so on. We can move up through those work coordinates. But most of the time I'm working in G54. So once we've established that job, now it knows where it's located. We have that same XYZ at the origin. Depending on how we manipulate the stock, then we can go back through and adjust for the oversize. New operation, 2D milling. We're going to be doing a facing operation. And then I have the same type of library of tools. Right? So this one is laid out. Let me stretch that out a little bit if I can. And we go to by type. I haven't brought them over, but usually in the My Libraries, all right, I do have a for the TM1. I have some default libraries. So we kind of started down that path with Mastercam. It's still something I recommend that if you have your favorite set of tools, even if they are not tool cribbed where they're living in the machine, having those tools available is pretty handy. So if I go with the TM because I'm out of an operation, and let's see, I used a 1/2 inch. All right, so we'll go to the TM2. I'll pick the 1/2 inch, and we'll select it. And then my defaults, I mentioned if I'm changing numbers more than a couple times, I'm writing them into defaults. So I'll have different machines with different RPM levels, and their tools will be copies of each other, but I'll go through and I'll take the time to build in the feeds and speeds that I want to run for that machine with that tool. So when I select it, I'm pretty much looking at this and going, yep, that's it, next. All right, we go over to what it's going to cut. And because this is a facing operation, it looks at the extents, the boundaries of that that face that I basically the XY plane and the coordinate system, our heights, clearance, retract, and feed. So these are incremental values, and this is one of the things I found confusing when I first started using HSM, is that model top is 0 and model top is 0 for the facing operation. We would expect that. The feed height is 0.2 and the retract height, so we can kind of manipulate those. Those are both at 200 thousandths. But then the retract height is, the clearance height is from the retract height. So it comes over here and says that's 0.2 plus 0.8. That makes a clearance height of 1 inch. So you can set those incremental values and have them add up, stack up as you go. And there are some advantages to that maybe I always want to have the same separation between my clearance and retract, but maybe I want to bring that retract or that feed height just a little bit closer and be able to adjust it feed rate or however far I want to pull it. So I play a few games with these just to again, depending on the machine, how much clearance I need, what I'm trying to achieve with those values. The phase tolerance and then the step over defaults to 90%. So 475, maybe that would be 95% of the tool diameter. So a little bit wide there. Maybe let's drop back to 300. If I want to set an angle, pass direction. Oh, and then the tool tips are pretty good on this this program. There's not an extensive help file, so a lot of times you just hover over and you go, oh, that's what that does. So it's kind of at your fingertips. And then the pass extensions if you want to include them, and then the stock offsets if it's needed. See, enable to use roll-on cut to keep the chips thin, multiple depths, directions both ways, and if we want any stock to leave. And I jumped over the from other side, both sides. All right, so allow rapid retracts, keep tool downs. I do want to extend before retract, otherwise the tool comes right up to the edge of the part, pulls out. This does have an interesting, HSM does an interesting lead-in. It will switch to G18 or G19 from G17 XY plane, and it will do this little arc ramp in. First time you see it, it's guaranteed to freak you out. So about 50 thousandths on the lead-in, I'll go ahead and leave it on this one. And then with the smooth transition, straight line, or no contact, we'll stay with smooth. And that'll give us the arcs at the end. So what you can't quite tell until you zoom in on it is it's coming in 50 thousandths above that face. It switches over to G18 into the XZ plane, ramps in, switches back to G17 XY and starts into the movement. And on the end, does the same thing. So since it's moving, if we didn't include the extended end, then it would just kind of get to that point and start ramping up. So it's not like it would stay there and just perform the swirls. It's just, like I said, it's a little disconcerting to some when you're not used to that type of ramp. All right, new operation. We'll go with the 2D milling, make it a contour. We're going to stay with that 1/2 inch tool. I select. It finds its way all the way around because we have tangent propagation and propagation along Z. My little arrow is to the interior, so it's going to blow out the center of the part. We need to reverse it. That puts the arrow on the outside. I can verify that I'm in climb. But if I did want to be in conventional, I really think these two tabs should be on the same, or these two operations be on the same tab. But if I come over to passes, there's my right compensation, there's my left compensation. So I still have that ability to change directions. 4,000 at 12 for this machine is fine. We have the edge. We'll go to the retract. So I've changed this one to 100 thousandths above the part and 0.9. And then for the default, it went back to 10 thousandths. So I actually want that 10 thousandths, but not on all of my contours. So since I see that as a possible problem, especially if I'm contouring, contouring something that is interior geometry but doesn't need that, I still want the default to be 0, so I can right click and say make 0 the default, even that I'm going to come right back and change it to a minus 10 thousandths. Next time I see that operation, I want to see that at 0. Right? And if I don't like any of these numbers or I decide I need to modify them, it's as easy as changing it, make default or make all default if I want to change, if I've changed more than one. Okay, so heights, let's expand that back out. This is going to be the roughing. We're going to leave a little bit more on the wall. We'll leave the 10 thousandths and nothing on the floor. Right, we left the 10 thousandths back over on the other one in computer. And if I repeat the finish pass, because I'm going to turn the ramping on again, let's see, feed in at 300, but I don't really want it to arc in, so I'm just going to hit 0. I could also have it do that little swoop in. Problem is also that some controls don't like that switching and swooping in and then switching right back. It freaks them out. So I would say just be careful of that vertical lead-in radius when you encounter it. So 5 degrees with a 0.25 ramp step down. And it's become my habit to, as long as I have that 100 thousandths feed plane, that I will let it continue on about 30 thousandths above the part. So it's really close when it starts in and barely makes it around the part before it starts the tool engagement. And then it started in the middle, finishing in the middle. And that should have just a little bit of a ramp out then. Maybe not. I'm expecting that to move out just a little bit on the out feed. So it sort of did it on the end. Now, go back and look at that one, and then if I duplicate it, that gives me an exact copy. We can edit it, and then I work pretty much backwards through. I don't want the ramp. We'd have to look at the lead in, lead out, and if it picks up the midpoint again, then we will go back and give it a location to start from. So I'm going to go ahead and accept that one. Yeah, so it kind of overlaps right there at the corner. So if I edit that one, this one might be better to go ahead and lead in, lead out, is we go ahead and put that little bit of an angle, even if it's 10 degrees. That should give me enough to start in and swoop off of the part so that it's not contact down the edge. So just a little bit of an in, a little bit of an out. All right. New operation, 2D milling. So we have the 2D pocket. The pocket doesn't have a lot of options. It's just going to do that step over and cut for the most part. So if we go to adaptive clearing, I can stay with those numbers. I want to do something pretty similar. So the model, I should find the face. Actually, I think I'm getting those backwards. We want to do that one, and then we'll pick up the contour. 400 thousandths above the part, 200 thousandths above the stock, and then from the contour minus 10 thousandths, and step over of 20 thousandths optimal load. We're pretty much burying that half-inch tool 1 inch deep, and so the amount of step over, I'm going to go down to 100 thousandths. And then stock to leave, nothing on the base, nothing on the floor, and we'll leave 10 thousandths again on the wall. All right, ramp, 2 degrees. Let's see, the ramp clearance height will go to 30. And the step overs, helical ramp diameter, minimum, we'll just tell it to go, it doesn't like 0, so 100 thousandths. Reduce it. Let's go ahead and see if I selected correctly. I think I got those backwards. So ramps in, steps over, and then takes that one little lip out. So this doesn't have the finish pass included in it. So we're going to go to new operation, 2D milling, 2D contour. Same basic tool settings that we had before. Pick up our edge, arrows to the inside. And let's go 10 thousandths past for the cleanup. We'll turn our wear on so that we can control the diameter. And stock to leave gets turned off. Don't need the ramp, but I do want a little bit more on the arc. So 45 degrees, 0.1, 0.1. We'll see if that has any gouge in it. All right, so feeds in, goes around, feeds out. So this was my setup 1. So I'm going to add that real quick. And then new job. We'll go right back through the same set of selections. Relative size box, no additional stock. Pick the face for the orientation, the direction for the x-axis, the location for the origin. I don't like its we did want it selected, so the edge, reverse. There we go. So we reverse the x-axis, that rotates it around. Now I have the correct geometry, 1, and probably should have put that in the other one, but block setup 2. And then we'll just rename that job. And new operation, 2D milling back to the face. Right, since it's a new job, it's still showing, well, tool selected none. Let's go ahead and pick it. Here's all the operations that are being used by that tool. And again, because it sees the face, we know that in theory we had 1/4 of an inch. So the feed height, let's do a 0.25, actually 0.3. And then we'll let it go from the feed height to the 0. Still a little bit thick there, so 0.3. Direction is fine. And let's just go ahead and turn the lead in, lead out entry. Actually, those were the arcs. So if I set that to 0 and extend before retract, should have enough to clear the ramp. So red is where it's feeding down, feeds across. Green is where it feeds out. So as long as everything looks pretty good, don't have to worry too much about the extensions. It's simulation is we're going to do stock simulation, and we'll rotate over. I don't really do the tool holders, so we can turn off the tool holder, set the speed. Otherwise, it'll blow through it so fast we won't really see it. Works back and forth across the face and makes the cuts. Yeah, there really isn't much material since we did not oversize the stock. What I'm mainly looking for in these, I don't see any heavy gouges, any ramps that take off through the part, or anything that looks crazy stupid as far as a collision. And then the finish pass. So if I knew I was going to finish over there, I could change the entry to be a little bit closer, but don't really mind it jumping up and over. Right, and again, with the this being dynamic, these fall into the trochoidal cuts. So instead of a pocket being, because of the length, we're getting that one little, the length of cut of the tool apparently is 3/4 of an inch, or is exactly 1 inch since it didn't clean out the entire top. So that looks a little bit weird, but with that that dynamic cut, that's going to generate at least a couple hundred lines of code, if not 500 or 600 lines of code, just to do that pocket and keep it engaged, because it's treating it as all those continuous XY points as it makes those arcs. And then when it gets to the end, it does the GO2, GO3 around the outside. So that looks a little weird. It's still not one that concerns me. I'd go back and check my tool length, or make sure that I had the shank included. So worst case, the shank would collide and finish it out. All right, so like I said, HSM, a little bit lighter learning curve. It has quite a few powerful tools in it, and it does all the way up through the multi-axis. I haven't tried the 2020 version with the lathe. The way that they manage their retract planes, the lathe has been problematic for boring bars. Those internal geometries tend to have issues. So hopefully they've gotten that fixed, and I will be able to, we'll take a look at a lathe part later on. So that gives us our view of HSM.